if extraterrestrial alien probes are already in our solar system, maybe we could detect them calling home. This is by Matt Williams, Universe Today on phys.org. It's been 70 years since physicist Enrico Fermi asked his famous question, where is everybody? And yet the tyranny of the Fermi paradox is still with us and will continue to be until definitive evidence of extraterrestrial intelligence, ETI, is found. In the meantime, scientists are forced to speculate as to why we have not found any yet, and more importantly, what we should be looking for. By focusing their search efforts, researchers hope to determine whether we are alone in the universe. In a recent study, 2 researchers from the University of Liège in Belgium and the Massachusetts Institute of Technology, MIT, recommended that we look for evidence of transmissions from our solar system. Transmissions from our solar system. Based on the theory that ETIs exist and have already established a communication network in our galaxy, the team identified Wolf 359 as the best place to look for possible interstellar communications from an alien probe, a space alien. The study, which is being reviewed for publication in the monthly notices of the Royal Astronomical Society of the UK, was conducted by Michael Gillen and Artem Burdanov. Gillen is a professor of astrophysics at the University of Liège in Belgium, a senior research associate with the Belgian National Fund for Scientific Research, NSRF, and a member of NASA's Nexus for Exoplanet System Sciences Nexus. And Burdanov is a postdoctoral associate with the Department of Earth, Atmosphere, and Planetary Sciences, EAPS, at MIT. Additional insight and support came from Professor Jason Wright, a Penn State Center for Exoplanets Habitable Worlds member, director of the Penn State Extraterrestrial Intelligence Center. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. So the Extraterrestrial Intelligence Center, like many who have proposed resolutions to the Fermi paradox, Gillen and Burdanov began their study with the assumption that extraterrestrial life has had a significant head start on humanity. Of course, that's the assumption because of the fact that they have such advanced technology that they would have interstellar travel. Now, from a cosmological standpoint, this is a pretty safe assumption. According to accepted models, the Milky Way galaxy formed roughly 13.51 billion years ago, followed by the first planets 500 million years later. Our solar system is a relative newcomer, having formed 4.5 billion years ago, and humanity has only existed for the last 200,000 years. It stands to reason that intelligent species have already emerged and have had the necessary time to colonize the Milky Way. Now, in their study, the team built upon a 2014 study by Gillen that showed how the ETI, extraterrestrial intelligence, could have filled our galaxy with self-replicating probes, von Neumann machines. This idea is similar to the theme to the Berserker hypothesis, but with the caveat that these probes were built for peaceful exploration. These probes, he argued, could form a galaxy-spanning communication network using stars as gravitational lenses to maximize their communication efficiency. As Gillen told Universe Today via email, this activity would constitute a viable techno-signature that could be detected. So this is what they want to look for. In this hypothesis, every star of the Milky Way should host such probes, including our Sun. This hypothesis tells us where to look for these probes at the solar gravitational line, SGL, of the nearest stars, hence at the opposite coordinates to the nearest stars. I explored this hypothesis further by considering different possible methods to detect these probes. He goes on to say, The problem is that the SGL is very far from our sun as it starts at 550 astronomical units, so any communication device out there would be extremely difficult to detect. Remember, 1 astronomical unit is the distance between the sun and our Earth. That's about 93 million miles. This was the main conclusion of my 2014 work. He says it's because of the passage is so far away, we can't detect them. Searching for these probes is worth a try, but we would need to be very lucky to detect anything, he says. In this study, Gillen, Bogdanov, and Wright focus on how humanity might detect interstellar messages coming from these probes, which they refer to as focal interstellar communication devices, FICDs. For this, they identified Wolf 359. It's an M-type red dwarf star located with 2 possible exoplanets as the best target for such a search. Of course, it's like trying to find a needle in a haystack this way. They just took a red dwarf planet star, and they said, we'll work with that, but it could be nothing there. Now anyway, at a distance of about 7.9 light years, Wolf 359 is the 3rd closest star system, Alpha Centauri and Barnard star, excluding Lumen 16, a brown dwarf 6.5 light years away from us. According to research published in 2019, Wolf 359 is suspected to be very similar in structure to Proxima b, the closest star system to our Earth, 4.24 light years away from us. Both systems consist of a low-mass red dwarf star with 1 closely orbiting planet, up to a few times as massive as our Earth, and a more distant larger planet, possibly a gas giant. However, unlike Proxima b and c, Wolf 359 system of planets has not yet been confirmed. After releasing his 2014 study, Gillian noticed that this Wolf 359 happens to lie in the ecliptic, the orbital plane of our Earth. In short, Wolf 359 is viewed edge-on from Earth and vice versa, which means that observers in either system would be able to see exoplanets making transits in the other. This arrangement, says Gillen, would also allow FICDs to send interstellar messages with a regular frequency. He says, due to this particular position, the Earth should lie once per year in the communication beam at the putative solar probe emitting towards Wolf 359. He says, I made some computations that made me conclude that if the probe emits to Wolf 359 in the optical range when the Earth is in its beam, we should be able to detect its emission even though with a modest size telescope. And this position is taken once a year, as we said. Now, to test this hypothesis, Gillen consulted data from the Transiting Planets and Planetesimal Small Telescope South, that's the TRAPPIST-South, and the Search for Habitable Planets Eclipsing Ultra-Cool Star South Speculoos-South telescope. These telescopes are located at the European Southern Observatory, ESO, La Silla and Paranal Observatory, respectively, in northern Chile. Using these instruments, Gillian observed Wolf 359's SGL for signs of communication emissions at the corresponding time of the year. Bogdanov explored the data further for signs of a slow-moving object whose motion conformed to what one would expect from such a probe. Unfortunately, neither the telescope data nor Bogdanov's targeting search indicated FICDs in Wolf 359. Interpreting this null result is difficult, as tons of hypotheses could explain it, said Gillian. However, he also explained how these results could create new opportunities for future SETI surveys. He said, while considering this null result, I realized that the emitting probes could be off-axis and much closer to Earth than the SGL, and that they could maybe be detected directly in imagery. The possibility of off-axis emitting probes opens a new avenue for the search for alien devices in our solar system. We intend to explore it further, observing the antisolar coordinates of the 10 to 20 nearest stars with our telescopes. We also observe the ones of our system, TRAPPIST-1, just for fun, he says. Surveys for extraterrestrial probes will also benefit from the many next-generation instruments available in the coming years. These include the Vera C. Rubin Observatory that will survey our galaxy, measuring the expansion of the cosmos, and map out the objects of our solar system, including interstellar objects like Huma Huma. The James Webb and Nancy Grace Roman Space Telescopes will be able to visualize objects with far greater sensitivity and precision. There's also the extremely large telescope ELT, the giant Magellan telescope GMT, and other ground-based observatories that will become operational in the coming years. These observatories will study objects that are too faint for existing telescopes using a technique called direct imaging. When these instruments begin gathering light in the next few years, adding possible FICDs to the list of potential targets could prove beneficial. Now, I don't know why they're only seeing whatever, stars. They could be looking for planets. They should be using far infrared telescopes that see cold things as well. This is by Universe Today, Michael Gillen, Artem Burdanov, Search for Alien Communications from Solar Systems to a Neighboring Star, today's article on FIS.org. Please leave your comments and thank you for your support.